Today we're going to extend the ideas from last time about how we can count and techniques. Instead of doing the problems willy-nilly and just trying to do it with brute force, we're going to use a principle which is called the fundamental counting principle. Then, gearing up for the next couple of classes, we'll be talking about factorials. Alright, so what is the fundamental counting principle? It says that if you have a job that consists of k tasks, and there are n1 ways to do the first task, n2 ways to do the second task, etc., then the job can be done in n1 times n2 times n3 all the way up to times nk ways. Now, this is a lot to parse, but we'll do many examples, and we actually saw 2 examples last time of the counting principle. Alright, so how can we use this? Well, last time we did an example with a tree with the outfits. But if we needed to choose a pair of pants, we have 3 ways to do that. So the jobs here are actually choosing the outfits. The first task, choosing the pair of pants, the second task would be choosing the shoes, and the third task would be choosing a shirt. The first task of choosing pants can be done in 3 ways. 1 for each pair of pants. For task 2, which is choosing shoes, that can be done in 2 ways. And choosing a shirt can be done in 2 ways as well. So when we multiply 3 times 2 times 2 together, we get 12. If you recall last time, we also got 12 by making our tree. Here's another example. How many ways can 3 chores get done if there are 4 kids doing the chores and they can do multiple chores? I think about this one a lot because I had many siblings, and at dinner time one of us would have to set the table, one of us would clear the table, and another one of us would do the dishes. So we always had 3 chores to do. Well, if there are 3 chores, that tells us that there are 3 tasks. Doing chore 1, doing chore 2, doing chore 3. Each chore can be done by 4 kids. So there are 4 ways that the first chore can be done. There are 4 ways that the second chore can be done. And there are 4 ways that the third chore can be done. This is also because kids can do multiple chores. When we multiply 4 by 4 by 4, we get a grand total of 64. We can modify this slightly, so again this should sort of seem similar with drawing the balls out of the hat from last time. Now, instead of letting the kids do multiple chores, we'll assume that they can't. So once a kid has done a chore, they've completed their activity. Alright, we still have the 3 tasks representing each chore. But now we have 4 ways that the first chore can be done. Once the first chore has been done, one of the kids has already done this and they can't do another chore. That means that we now only have 3 options for doing the second task or the second chore. Once we've done those 2 chores, the third chore has 2 kids that could possibly do it. So we multiply the 4 times 3 times 2 to get 24. Alright, we are now ready to talk about factorials. N factorial is the number gotten by multiplying n by n minus 1, by n minus 2, all the way down to 1. It's going to be important to know how to multiply these factorials, but this formula is a little bit confusing, and in practice it's actually easier to use. So, if I asked you to find 5 factorial, this would multiply 5 times 4 times 3 times 2 times 1. Now, it doesn't really matter how you multiply these. I've grouped these together by first multiplying 5 times 4 to get 20, and then 3 times 2 times 1 to get 6. Then I multiply 20 by 6 to get 120. An important fact is that 0 factorial is equal to 1. This does not follow the formula, and so we're going to take this as a fact. Now let's do an example. Suppose we wanted to find 7 minus 4 factorial. We must abide by order of operations, and so we will first subtract 4 from 7 to get 3, and then compute 3 factorial, which is 3 times 2 times 1. That gives us a grand total of 6. Here's another question. I could say, what is 2 factorial divided by 0 factorial? This might feel a little strange because we have a 0 in the denominator, but remember that 0 is not the same as 0 factorial. So, we can find each of the following. We know that 2 factorial is 2 times 1, 0 factorial is 1, and so 2 factorial over 0 factorial is the same as 2. Another way that we can apply factorials is in the following type of example. Suppose we wanted to find n factorial divided by k factorial times k plus 1 factorial. And then I'll tell you that n is equal to 3 and k is equal to 2. So we substitute in the numbers, 3 for n and 2 for k, and we end up with 3 factorial all over 2 factorial times 3 factorial. And then we can write each of those out. We can then actually cancel some of these numbers because we have a 3 on both the top and bottom, a 2 in both the top and bottom, and a 1 in both in the top and bottom. And we end up with a 1 over 2 times 1, which is 1/2. Alright, that concludes our lesson on the fundamental counting principle as well as factorials. Next class we'll actually use factorials to use in formulas to compute other types of counting.